Hi, today I'm going to introduce you to trigonometry, which is the study of triangles, and later on you will also get to know what this acronym means. So there are two things I'd like to ask you. So right here, I'm going to show you 5 triangles, and of course ask yourself, what do these triangles share in common, and what sets these triangles apart? So here are just 5 triangles, and what makes them similar and what makes them different. So if you thought about it for a second, you would see that all of these triangles are right triangles. They have 2 sides that are perpendicular and they meet at a 90-degree angle. But what makes them different is their acute angles are all different. So they have like different shapes. This one's really skinny because that's a really small angle. This one is kind of even, like both of these look kind of the same. And they're each different from one to the next because each of their angles are different. So in trigonometry, you learn about functions that tell you this shape if you know the angle. So before showing you those functions, you need to know some trig vocab. So here's a triangle, and there are 3 sides in a triangle, but in a right triangle there are names for each of them. So say you're looking at an angle called x. It could be like 60 degrees or 89 degrees or 1 degree, it doesn't matter. But the side that is opposite that angle is called the opposite. What defines an opposite side is just the side that doesn't touch the angle. So these other 2 sides, they do touch the angle right here, but this side does not. Also, if I were to make an angle with my fingers right here, the side that connects them or doesn't, that I make with the angle, is this line. So that's how you can visualize opposite angles. The adjacent side is the side that touches both the angle that you're looking at and the right angle. If you were observing this angle, like you can call it y even, the adjacent side of the angle y is this side because it's touching this angle and the right angle. But for now, just think about the angle x. So the one adjacent is the one that touches x and 90 degrees. Now the side that is opposite the 90-degree angle is called the hypotenuse. So this is a really important side because it's the longest, because it's opposite the biggest angle. In any right triangle, the hypotenuse is always the longest. See, this side, this side, this side, this side, and this side, they're all the longest side of each of these triangles. And that's always true because it's opposite the largest angle. And if I were to use a rubber band again, if I were to create 90 degrees, the rubber band is the side opposite, also known as the hypotenuse. So now that's all you need to know to understand the 3 main trig functions. So there are 3 main functions which are called sine, cosine, and tangent. And these are the ratios of 2 sides in a triangle. So sine is the opposite side divided by the hypotenuse. The cosine function is the adjacent side over the hypotenuse, and the tangent function is the opposite side over the adjacent side. So given an angle, each angle makes a different triangle, as you can see here. So each of these have different ratios, and that's what the function is supposed to tell you. It gives an input, or you give it an input, and it outputs the special angle that's unique to each of these triangles. SOHCAHTOA, the title of this paper over here, is an acronym to help you remember all of those things. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And right triangles don't always look like this, or not always flipped this way. Sometimes, like in this one, you'll have it like that. If you were to take the tangent of this angle here would be this side divided by this side. But you know, it doesn't matter which way you look at it. It just, what matters is the angle that you choose. So what do these functions mean geometrically? Or what do they mean visually? So let's say, you know, there are all these different examples, but let's go left to right. So, for example, if cosine of an angle x is equal to 1/2, that means the hypotenuse is double the adjacent side. That's because cosine is equal to adjacent over hypotenuse. And so, if the side length is 1, then the side length over here is 2. Or if the side length was 2, then this side length here would be 4. And if it was 4, then this would be 8, and so on. If sine of x is equal to 1/4, that means that the hypotenuse is 4 times as long as the opposite side. And that's because sine is equal to opposite over hypotenuse. And again, if this side was 2 instead of 1, then this side would be 8. If this was 16, then this side would be 32. That's just, you know, it could take a whole bunch of different things, just because it's just a ratio, and ratios stay the same no matter how big you make it. And if tangent, for example, is equal to 1, that means that the opposite and the adjacent sides are equal, because tangent is opposite divided by adjacent, and 1 is equal to the fraction 1 over 1, and you can figure out the rest. So moving on, all triangles are similar if and only if they have the same trig values. So that just means that if the triangles are similar, they will have the same trig values, and conversely, if they have the same trig values, the triangles are similar. So here is an example. Here are 3 different triangles. They're all 45, 45, 90 right triangles. And if you take the tangent of all of them, they're all equal to 1, because the ratio between them is always 1. Like, they're the same, they're equal. And whatever factor you increase or decrease it by, it's just going to cancel out. Like right here, this is increased by a factor of 1.5. So you multiply each side by 1.5, but then you cancel out that factor, so it just goes away. And you can see it visually just because it doesn't matter what you call this, just as long as, you know, as long as they're equal, then it's going to have a tangent value of 1. And that's all you need to know about similar triangles. But that also means that you can't find the length of a side of a triangle by only knowing its angle. Like, it's impossible. You have to know more than just the angle and sine, cosine, or tangent, because it could be any one of these. It doesn't just have to be side 2 if like the sine is equal to 1/2. Not at all. You have to know the length of another side. Like I said, you will need some other stuff, specifically 3 ingredients and 1 tool. That would be an angle, a side, the correct trig function, and most often a calculator. And I say calculator because most trig values, they're really like specific decimals and things that, you know, you can't remember, like the sine of 58 degrees. You can't really figure that on your own unless you have like really good math. But there are some special angles like sine of 60 degrees or sine of 90 degrees, which later on you will have to remember because those create special triangles. So if I were to give you an example of solving for the other sides of a triangle, it could go just like this. So you have a 60, 30, 90 degree triangle, and you know that the adjacent side, or the side adjacent to 60 degrees, is 1.5 inches, and you want to figure out the sides y and z. And I only want you to use this information. Don't use the fact that this is 30 degrees. I only want you to use functions that pertain to 60 degrees and 1.5 inches. So how would you do that? Try it for yourself, but if you're clueless and you have no idea what to do, I'm going to show you. And so first I'm going to solve for y. Earlier I said that you need the correct trig function, and the correct trig function is really easy to figure out. You just need to know like what sides you're using. So you know one side and you want to find the other, and so since we're dealing with 1.5 and y, or the adjacent side and the opposite side, that is the tangent function. The tangent function can help us with that because it uses these two things. If we were doing z and y, or the hypotenuse and the opposite, we could use the sine function, but we'd have two unknown variables, so that would get us nowhere. Here we're using 1.5 and y because we know something. We only have one variable. So here's the definition of tangent, which is opposite over adjacent. And then plugging in what we already know, tangent of 60 degrees is equal to side opposite over the side adjacent. And then multiply by 1.5 on both sides. And then you get 1.5 times tangent of 60 degrees is equal to y. So, and just so you know, tangent of any number is a number. This is not a variable. This is like some decimal or some integer, and that's because every triangle has a unique trig value. That is a right triangle, but they're all special, and so if you put it in a calculator, the calculator will spit out only one number. And so if you plug that in, you'll get 2.6 inches. And I can just measure the side right here, y. If it said that it was 2.6 inches, that looks to be about correct. That's 2.6 inches is pretty much that long. Now I want you to solve for z using trig functions, but you can't use your new knowledge of like y, how long y is, and you can't use 30 degrees. I just want you to use the information you have here. So only using this side and 60 degrees, the correct trig function would be cosine, because you have the adjacent side and the hypotenuse, and that's the cosine function. And so here, this is the definition. I'm plugging what we know. And then we're switching stuff around to isolate z and get it by itself, because that's what we want to know. And then plug this into your calculator and you'll get exactly 3 inches. And right here, if I measure it, this hypotenuse does look to be about 3 inches. And so the math checks out, and it would be even more exact if I had a super fine pen and the exactly 60 degrees. But for all purposes, that's all you're going to need. And I hope that this video helped you. If there's anything that you're still stuck about, anything that did not make sense, please comment down below anything that you'd like to see about trigonometry, or anything that you'd like help with or interest in math. That would be great. And I hope to see you next time. Bye-bye.